All right, this homework is making sure you understand how to work with the inverse of exponential functions. And part of that is understanding exponential functions. This entire homework is meant to be done without a calculator. So let's look at a few things here. We're filling out the table to be able to graph this. And for each x, we want to find what the output is. So when x is -3, we want to know what the y is going to be. And so we use the function 3 to the -3rd power. Negative exponents tell you to divide by, divide instead of multiply. So instead of 1 times 3 times 3 times 3, it's 1 divided by 3 times 3 times 3. And so 3 times 3 is 9, times 3 is 27. And so when x is -3, y is 1/27th. And of course, where that is on the graph is it's 1/27th of the way up to 1. So it's almost at 0. Like this point is very, very near 0. We can do the same thing for 3 when x is -2. The function says it will be 3 to the -2 power, which is 1 over 3 squared, which is 1/9, because 3 times 3 is 9. And that 1/9 is still fairly close to 0. It's a little bit higher, but it's still very close to 0. I'm not going to fill out all of these. I will show you a couple more. When x is 0, 3 to the 0 power, you're supposed to know there's a property that anything to the 0 power is 1, which is why all exponential parent functions have a point at 0, 1. When x is 0, y will be 1. And I'll fill out one more thing because it will give us a sense of our scale. So when x is 3, y is 3 to the 3rd power, which means 3 times 3 times 3, which is 27. So we just put in x is 3. And so when x is 3, I know I need the y value to go up to 27, and so maybe I need to change my scale, because if I just count by 1s, 27 won't be on there. So maybe I should count by 5s, 5, 10, 15, 20, 25, 30, and now 27 will fit on the graph. I'll have to change this point. This point is no longer at, we don't want it to be at 0, 5. We want the point to be at 0, 1, and so that would be down here. But that's okay. So we can change our scale so that 1 would be a fifth of the way up here, and we end up with, whatever ends up happening, we'll end up with this nice exponential graph that looks like this. This part C here said to graph the inverse function. And of course, for the inverse function, we can just switch the x's and the y's. We could make a table, or we could just literally take the x's and y's and switch them. Another option you had here was, instead of making the scale count by 5s, you could just say, look, this last point won't fit on the graph, but I'm comfortable fitting 6 of the points on the graph, and that's good enough, and it's okay for points to be off the graph. When you're doing, so I could have counted by 1s here. And just said, look, the point at 3 is going to be way off the graph. I will have my point at 0, 1. I will have a point at 1, 3, and 2, 9. And then after that, it'll be off the graph. And that's okay. You can make different choices that are still appropriate. It's generally good if you have a table to fit as many of the points as you can. But, you know, missing one of the points is okay as long as you have it well scaled. If we did it this way, the inverse function, instead of having a point at 2, 9, would have a point at 9, 2. So 9, 2. Instead of having a point at 1, 3, would have a point at 3, 1. And all log parent functions have a point at 1, 0, because all exponential functions have a point at 0, 1. So the log parent function has a point at 1, 0. This point was -3, 1/27th. So when I switch x and y, it becomes 1/27th, -3. And that means when x is just a little bit bigger than 0, y is -3. We can see that asymptote that goes with the log graph. So there we go. There is our graph, and we can see they're nicely reflected across the line, y equals x. Okay, what do I want to go over here? I want to make sure everybody knows the answer to 4. Again, you should never be doing these homeworks starting with the video. You should make sure you can do it as much as you can on your own, and use this only when you get stuck. Write an equation for f inverse of x. So f of x was 3 to the x. The inverse function we said was log base 3 of x. So the inverse of an exponential function is a log function. This is asking 3 to what power gets you x. I'm not going to go over any more on this page. I will go over a couple of these to make sure we all feel good about evaluating logarithms. Remember, a logarithm is saying the base needs to go to what power to get to 16. So it's saying 2 to what power gets us 16, and this is the answer to this logarithm. And so one way to think about it is just to start out multiplying by 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And so what exponent was this? Well, this is 2 to the 4th. So the answer to this logarithm is that log base 2 of 16 is 4. I'm going to go over C here. So this is saying x to what power gets you x to the 5th. So x to what power gives you x to the 5th. And even though this might look trickier because it doesn't have numbers, it's a much easier problem to answer. What exponent goes on x to get you x to the 5th? Well, the answer to this logarithm is 5. X to the 5th power gets you x to the 5th power. I think I'll go over one of these. We can see there's a fraction here. And so it's saying 3 to what power gets you 1 over 27. And you should see right away that to have it divide instead of multiply, we need this exponent to be negative. It's going to have to be 3 to a negative power. That will do the 1 over. And then the question is, how do we get to 27? Well, 3 times 3 is 9, times 3 is 27. And so we needed 3 3's multiplying together. And that will give us 1/27th. And so it's 3 to the negative 3rd power. So the answer to this logarithm is log base 3 of 1/27th is negative 3, because 3 to the negative 3rd power will give us 1 over 27. The last one I will look at is H here. So this is saying 10. So this is log base 10 of 0.0001. So it's saying 10 to what power gives us 0.001. And we haven't dealt a lot with decimals, so this is an interesting question. Well, we know how to rewrite decimals. 0.001 can be rewritten as a fraction. And so the fraction that this is 1 divided by 1,000. And we can see that because the decimal place moved over 3 times. And so the question is 10 to what power gets us this? Well, this is 10 to a negative power to make it be 1 divided by. And the decimal place needs to move 1, 2, 3 times, so it's the negative 3rd power. That's how we get to the 1 over 1,000. So 1 over 10 times 10 times 10, that will be 1 over 1,000. And so we needed 10 to the negative 3rd power. So negative exponents can get us to decimals. We'll talk more about this later in the year. I'm only going to go over one of these. We should be able to do some of these inverses. We know how to switch x and y. We know how to do inverse operations in the inverse order. I think the only one I will go over is C because it's a little bit new. So to find the inverse function, we need to first switch the x and the y. So y becomes x, and x becomes y. And now we need to get y by itself. We need to isolate y. We need to solve for y. Those are all the same thing. And so I need to undo the last operation that's happening here. So 3 is getting taken to the y power and then added by 1. So the last thing that's happening is adding by 1. So I'm going to start by subtracting 1. X minus 1 cannot be simplified. They don't combine. They are not like terms. 1 minus 1 is 0, and so that eliminates. And now how do I undo 3 to the y power? Well, this is where our inverse operation came in. The inverse of an exponential is a logarithm. And so we're going to do the log base 3 on both sides. Just like with multiplication and square roots and squaring, we need to do it to the whole side. So log base 3 of 3 to the y equals log base 3 of x minus 1. This inverse operation will cancel out, and we will get log base 3 of x minus 1 equals y. And it's important that this is in parentheses to be very clear about what's going on. This last one, I'm not going to tell you exactly how to do it, but I will give you a hint. When I look at this, after you switch x and y, and you're trying to get y by itself, the y is being added by 6. That answer is used to take 2 to that power. That answer is then subtracted by 3, and then the whole thing is divided by 4. So the last operation that's happening is divided by 4. and so you're going to undo that. Once you get rid of the dividing by 4, the last operation that's happening here is subtracting by 3. And so you are going to undo that next. The last operation that's happening here is it's 2 to the x plus 6 power. So it's 2 to this power, and to undo 2 to the power of something, you're going to need to do a logarithm. So log base 2. And the very last thing is once you get rid of that, you'll have x plus 6. And so adding 6 is the first operation that's happening to the x or the y once you switch x and y. And so you'll need to undo that last. Hopefully this is a good start to helping you on your homework.